Okay, let's continue with our discussion of the normal curve. And I was asking you in between presentations to grab your textbook, look in Appendix B, it's on page 400, and you'll see a table called Areas Beneath the Normal Curve. I think the table itself is called, Areas Beneath the Normal Curve. All right, so before we start, I want to revisit the example from before, and let's figure out what is the what percent of people did I score better than. So let me get my pen to working, excuse me. And okay, so if you remember back earlier in the PowerPoint, we were looking at a z-score of 0.6. All right, so we want to know for a z-score of 0.6, if I'm thinking about z-scores, I know they have a mean of 0, right, and a standard deviation of 1. So if this is 1, 2, -1, -2, and I know they're normally distributed. So if I have a z-score of 0.6, it's going to be what, like right here? So the question is, what is this? What percent did I score better than? I'm going to try to straighten up my line here. So this is my mean of 0, and this would be my 0.6. Okay? So the question is not just, hey, I scored better than average, but exactly what percentage of participants or test takers did I score better than? So I want to know this area over here. Well, I can figure that out by looking in the table in Appendix B. All right, so what I want you to do is look for a z of 0.6. All right, so if I'm looking for a z of 0.6, it's on page 400. It's in the 1 to 3rd column, a z of 0.6. All right, now I have a copy of one of those tables, but it's a little bit different. But let me go ahead and pull it up because I want to make sure. So you see it's similar, but it's a slightly different. But I can find a z of 0.6 right here. Okay, there's my z of 0.6. Now, if you notice, yours says 22.57. Mine, my decimals just moved over. It says 0.2257. So same information. It's just the decimals in a little bit of a different place. What I want you to do is look at the top of that table of the column. It says area between the mean and the z score, just like yours. Okay, so if I go down and I look, there's my mean of z, and I scroll over to my column, area between the mean of z, 22.57. Okay, so let me come back over here. So it's telling me that the area between the mean and the z is, let me write it down before I forget it, 22.57. All right, so that is talking about, here's the mean. Remember, the mean is 0. So this area right here between the mean and the z is 22.57. Okay, does that make sense how that table's working? The column is labeled the area between the mean, which is 0, and the z that I care about, which in this case is 0.6. So it's about right here. And that is 22.57. But I also need to know about all of this. And I can use what I know about the normal curve to help me. I know that it's symmetrical. So if I'm chopping it right down the middle here at 0, the mean of z, half of my curve is going to be worth 50 and the other half is 50. All right? So this part over here is going to be 50. It's probably not exactly 50, but we're going to treat it as 50 because it's half of our curve. right? Each half is worth 50. So to figure out all of this area, all of that percentage that I scored better than, I'm going to take my 2257 and I'm going to add my 50. All right, so 7, 5, 2, and 7. So 72.57. So by scoring a Z of 0.6 or a raw score of 81, I scored better than 72.57% of people who took the exam. Okay? All right, well, let's do some other examples and see if we can't hammer this home a little bit. Okay, so for a normal distribution with a mean of 100, okay, so, and for me, what I like to do is really think about first, okay, well, what are they asking me? All right, what proportion or percentage of cases fall below a score of 80? All right, well, I'm going to draw it because I love pictures and they help me think my way through it. So if I have a distribution and it has a mean of 100 and a standard deviation of 20, it wants to know what proportion of cases fall below a score of 80. All right, well, if my standard deviation is 20, I'm going to make my plus 1, 2, 3 and my minus 1, 2, 3. Okay, so I know that this is going to be 110. Well, I'm sorry, 120. Fix that real quick. Bear with me, please. Okay. Because 100 plus 20 is 120, 140, and 160, right? Then we would have 80, 60, 40. So they should go up by 20. So 40, 60, 80, 100. This is 100, 120, 140, 160. All right, and I know this is normally distributed because it tells me right here, normal distribution. All right, now it wants to know what proportion of cases fall below a score of 80. So if this is my 80, it's asking me, if this is 80, it's saying, what is this area over here, right? That's my question. I don't know what that area is, because it wants the area below 80. Okay, so first thing I need to do, because I know that my book is in z-score form, right? I know I can figure it out, but I've got to convert it to a z-score first based on what I was able to do up here. So I'm going to remember my z-score formula. It's how far my score is from the mean divided by the standard deviation. So for this, it's going to be 80 minus 100 divided by 20. All right, so 80, that's negative 20 divided by 20, which equals negative 1. Okay? So my z-score conversion, or if I have a raw score of 80, my z-score equivalent is going to be negative 1. So z equals negative 1. So if I am thinking, okay, this line is raw scores, but I can also, I'm going to erase this a little bit so that I can get some room in here. If I'm thinking about that z-score equivalent, remember it's the same data, it's just on a different scale. So if this is z-score, here's my mean of 0, then I have 1, 2, 3, 1, 2, 3, like that. So my z-score of negative 1 is going to be right here, right? Because it should be equivalent to the 80. See that? So it's still the same information, but now I have it in z-score format so I can use the table. Okay, so go back to your book, look for a z-score of -1. Now, before you get there, I'll tell you that the information they give you in the table is only positive. Because if we know that this curve is a mirror image, then whatever it reports for the positive side, it's going to be true for the negative side as well, right? Because it's just a mirror image of each other. So don't look for -1 because it's not there. Look for +1. And remember, this is 1.0, not 0.1 or anything like that. We're looking for a z of 1. Okay, the z of 1 is at the top of the 5th column, and it's a z of 1.00. That's on page 400. Now, I can tell you that some students in the class, for whatever weird reason, their book doesn't have some of the values. Like there was just a printing error or something. Some books did. My book does, but some other people's did not. So if you don't see a z-score that's 1.00 right on the dot, that's probably what happened. All right. So let me see if on my a little other version copy I have a z. Yeah, see, I have one. There it is. 1.0. It's 34.13 in your book. 34.13. So that is the area between the mean and the z. So let's see what that looks like. So the area between the mean, remember, which is right here, at 100 or at 0, so the area between the mean and the z, right, so it's this area right here, is the 34.13. 34.13. There we go. All right, so this area is 34.13. Now, my writing's getting kind of scribbly here, but it's not asking for this, is it? It's asking for this section over here. So even though the book tells us this area right here, we want to know this other side, don't we? Well, I know that half of my distribution is what? 50, right? Well, if the whole thing is 50, I should be able to take this part away and figure out what this remaining part is. Okay, does that make sense? So half of my distribution is 50. And then I'm going to take away what they give us, 34.13. That's really the wrong part of that 50, isn't it? We want this other part over here. So if I take that away, I can pop it in my calculator really quickly. So 50.00 minus 34.13 is 15.87. Okay, so this is 15.87. All right, so what proportion of cases fall below a score of 80? That's going to be 15.87. You can think percent, or you can just think proportion like they're asking. All right, so 15.87. Okay. Let's do a couple more. All right, in this case, for a normal distribution with a mean of 100, standard deviation of 20, what proportion of cases fall above a score of 120? All right, so let's look at it and see here. They want above 120. So we're starting with the same idea. And this time I'm going to start with my 2 lines because I know I'm going to have this raw score and I'm also going to have my z-score. And I know my 2 means. This is 100. And my mean of z-scores is going to be what? 0. Okay, so I'm going to go 1, 2, 3. 1, 2, 3. 1, 2. And I'm just going 3 standard deviations because I know that gets almost all the scores. Okay, so same thing here. If my standard deviation is 20, then I know this is going to be 120, all right? So this is the point, and it's going to correspond to a z-score, right? And here, let me draw my curve here. There's my curve. So I can then remind myself what it says. What proportion of cases fall above a score of 120? So I am looking for, maybe I could change the color and make it a little better. All right, so I know I'm looking for what's in blue right here. Okay, so this is my question mark. What is this, right? Well, I can go ahead and convert to a z-score, because I know I need to convert that 120 so I can use my book. Now you may have already can tell what it is, but I'm just going to work through it just in case. Okay, so my score is 120 minus the mean divided by 20. Okay, so when we convert that 120, that's 20 divided by 20, which is 1. Right, so z-score of positive 1. See how it's just the same? There's, it's going to erase it. There's my z-score right there at 1. And it makes sense. So because my 120 should line up with my z-score because it's just a different scale, right? A different metric. So I'm still looking for this part. But now I have that z of 1 that I can look in my book for. And didn't we already look up a z of 1, right? Because we were looking at negative 1, remember? And so the book told us that for 1, it's 34.13 is that area between the mean and z. All right, so I'm going to try a different color here. So if I'm thinking about, I can get it to click over for me. Yeah, okay. So if the area between the mean, which is right here, so the area between the mean and z, of course. Oh, goodness. Okay. Try it one more time. If the area, that's a terrible line. Okay. That is ridiculous. I'm sorry. Bear with me. I will get better at this, I hope. It doesn't help that a little bit OCD, trying to make everything perfect, right? Okay, so the area between the mean and z right here is, same thing it was last time, it's that 34.17. And just like last time, we know that half of it is equal to 50. So if we take our 50 again and take away that part we don't care about, 34.17, we should get what? 15 point, what was it up here? Remember? 15.87. Oh, so it's 34.13. I thought that looked a little wrong, a little off. Oops, there we go. 34.13. Sorry about that. I knew it was 15.87, but that's where that 7 came from in my head. But anyway, so the scores above this blue part is equal to 15.87. And it's kind of good that they that we're being asked these questions kind of back to back, because if we know that if we know that this area is 15.87, it makes sense that this area, because our curves are symmetrical, would also be 15.87. All right, so it's not so bad, is it? Let's go on to the next one and look at a distribution with a mean of 100 and standard deviation of 20. What proportion of cases fall above a score of 80? So I'm going to draw it, but then I think we'll be able to use what we've done already to help us. And I'm going to draw my z-score line down here too, just so I'll make sure and have some room. All right, 1, 2, 3, 1, 2, 3. And I know that this is 100, standard deviation of 20. So it's asking about 80. So I know my 80 is right here, which is going to be equal to a z-score of what? -1 again. Remember that? How we've already figured that out? There we go. Okay, and we have our nice normal curve. All right, so let me figure out, what are they asking me? They want to know what proportion of cases fall above a score of 80. All right, so here's my 80. So they want to know what is all of this area. So that's my question mark. What is all of this? All right, well, the good news is, based on the other questions I've answered, I know that this area over here was what? It was our 15.87, right? So if this is 15.87, how do we figure out this area? Wouldn't it be just the 100, the whole thing? Take away that part we don't want to include, the 15.87. And so what would you get there? Well, we know we're going to have 13 left. And then what would that be? 84? You check that on your calculator just to make sure. 100 minus 15.87 is 84.13. Yep. So this here that they're asking for is your 84.13. All right, so we're getting faster at it, right? We're getting better and better. Let's look at this one. This is our last one. All right, so again, normal distribution. Doesn't like me to click with that thing. Okay, normal distribution, same thing, mean of 100, standard deviation of 20. This time they're asking for something a little bit different though, so we'll work this one out. A mean of 100, standard deviation of 20, 3, 1, 2, 3. What proportion of cases fall between the values of 90 and 120? If I have a standard deviation of 20, I know this first mark is going to be 120. Right here. Okay. And then 90, if this is, I know this has got to be 80, right? Because it has a standard deviation of 20. If that's 80, I know 90 is going to be right here in the middle. Right in between those two. If it keeps erasing my mark. All right, right in between those two, that's going to be your 90. So if I'm thinking about my curve, I know I'm going to be looking for information between these 2 points, between the values of 90 and 120. So I want this info. This is what I'm curious about. All right, so I need to be able to figure that out and use my book. I've got to convert them to z-scores. So let's do 90 because we've already figured out 120. What was 120 converts to a z-score of what? That's a z of +1, right? But let's see what 90 converts to. So remember, z-score is our score minus the mean divided by the standard deviation, which is, I'll go ahead and just put 20. Okay, so we've got 90 minus 100, which is -10, divided by 20, which equals negative what? To -0.5. All right, -0.5. So I have one z of 1 and one z of -0.5, which, remember, for our table, we're just going to have to disregard this negative. Okay, so we've worked with a z of 1 before, so we already know that almost all of this right here is going to come from our table. So the area between the mean and z, which is this, because our mean is 100, and our z is 120. So the area between the mean and z, when we looked it up a couple of times, we found it to be what? I probably can't remember it. Let me look back here. 34.1, but it wasn't. Was it 17? 13. 34.13. All right. So this was 34.13. Well, let's do the same thing. That's a 4. Let's do the same thing for this little area over here. I'll change my color. This little area right here is what we need. We need the area between this z, which is right here, and the mean. So just pretend like poor people having to deal with my awful drawings. But between a 1 and a negative 0.5, or 90 and 120, that area would be this, and then also this blue area. So let me look up 0.5. You do the same. 0.5 is at the top of the third column, and it's 19.15. 19.15. All right. 19.15. That's that right there. I'm going to pull up my table again, just in case. If I look up 0.5, here we go, right here. 0.5, if I scroll across, 19, remember your decimal's in a different place, 19.15. All right? So that's where that came from. Okay, so to figure out this area, of course, we just take those two and put them together. So 34.13, 19.15. So that's 8, 2, 13, 3, 4, 5. 53.28% of cases fall between these two scores. So about half of people, right, scored between a 90 and a 120. As an educator, that could be really interesting. So before we leave standard scores, what I want to say is when we get into statistical significance testing and we're looking at the likelihood of a result, we're going to start, and you've probably heard of or maybe even know about p-values. P-values are probability. The probabilities are going to come from exactly this type of thing. So whereas you have in your book 53.28 is what we calculated, or the 19.15, or the 34.13. When we start talking about probabilities, what we're going to do is move that decimal. So we're going to say 0.5328 and 0.1915. So what this will do is it'll allow us to talk about what's the probability of us getting the result we got, whatever that result is. Okay, so when we get into probability, I'm going to bring you back to this normal curve and remind you that all those probabilities are the likelihood of a result. Okay, so you can kind of get a little glimpse into how what we're doing now, just talking about proportion of cases, is going to be used in everything we do in the inferential and then everything next semester. All right, well that is the end of standard scores and the normal curve.